Okay, so now we are going to simulate the use of a Jupiter on the field. So to do this, we will use this electric cable, because basically the Jupiter can work on dead cables. So it can be high voltage, low voltage, medium voltage, any kind of electric cables. We can use the Jupiter on it. So for simplicity reason, we will use this electric cable. The very important thing you need to know about the Jupiter is you need to be short-circuited on both ends of the cable. So here on the simulation, we use these clamps to short-circuit the cable this side and the same on this side. First of all, we are going to set up the transmitter. So to do this, we will connect the clamps on each phase. So it's very simple to use because you have the phase number on each clamp. And the only thing important about installing properly the transmitter is that all the arrows must point the same direction. So here they all go inside the cable, the same, so they go inside the cable. That's the only thing to know about the transmitter. And on the transmitter in itself, it's very simple to use it because you just have two buttons, on and off. So to start it, you just push the green button and then you're sending a frequency in the cable and there is nothing else to do. So no calibration, nothing. It's very simple to use and anyone can use it because there is nothing to know about it. And now we are going to use a receiver, and with the receiver you can do four things. First thing, you're going to use this receiver, which is always the same, and depending which probe you use, it will automatically set up the good mode. So this is military connection, so it's done for the field again. And first of all, you can go. So basically, you're on the field, and your transmitter is connected. You're sending the signal, and here you're on the other side of the transmitter. And you're going to, first of all, check that each phase corresponds to the phase on the other side. So basically you check that phase 1 is phase 1, phase 2 is phase 2, and phase 3 is phase 3. So you take this clamp, and we're going to come around one feeder, okay, in the post. And it's very simple to use, so you just have to push this button. And it says short circuit identification, and then it says phase 2. So we say that the maroon one is phase 2, and if you come back here on the transmitter, you see that the maroon one here is phase 2. So basically at the same time you confirm that this is a good cable, and at the same time you confirm that phase 1 in this post is the same than phase 1 in this post. Because sometimes when you cut a cable and you reconnect it, it's not connected well. So that's what you check first. So we can do this for the second one, the blue one, which should be phase 1, and with this one, which should be phase 3, obviously. Okay. So first of all, we confirm that the network is well connected. Secondly, you can use the same receiver, and now we are going to go on the field in the trench. So we will simulate that between these two posts there is a big distance, and we have this trench here. So with one cable, the good one, and maybe another one, and maybe 5, 10, 20 cables. It doesn't matter. So we will connect this probe, the same principle, and here, as everyone can use it, you will see that if you just push on measurement, it's in pre-identification. So pre-identification means that you're going to identify the good cable. So here it says no, because I'm not on my cable. But now, if I just come on the cable like this, and I push on the same button, it will calculate and give me a simple result, yes or no. So everyone can find the same result. Here it's yes. So now you know this is the good cable. This is the cable you can cut because it's dead, and that's the good one. And if you have any other cable on the side, it will say no. So you will have no, 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 yes, no, no. So you know which one is the good one. Now, third step. Let's say that we cut the cable. So if we cut the cable, basically we are on open circuit. So we will just remove, to simulate, we will just remove the short circuit clamp. Okay. So now we have another option, which is called the continuity. So with the continuity, basically you find on which end is the transmitter. So here on these two okay, when we start, it's written continuity. Okay, it says yes, because it means yes, the transmitter is on this side. If I could access the other end of the cable, it would say no, because it would mean no, there is no signal on this side. So now I am in my trench, and I know that my cable comes from here and goes in this direction, because I've got the signal on this side. And to finish, a very important option is the fact that you can find the phases in the trench. So to find the phases, use the red probes, and you're going to, it's very simple to use, it's a deductive method. So you will connect, you will basically touch two phase. So here I'm going to touch phase 2 and 3, and it will display the phase 1. So this one is phase 1. So it's a deductive method. I will touch two phases, and it will show me the phases that I don't touch. So here in this situation, the blue one is phase 1, and my blue one here is phase 1. Now if I just want to confirm, I can touch the blue one and this one, maroon, and I will find phase 3. Phase 3. So this is how Jupiter works, and as a conclusion, we can see it's a very simple equipment. Easy to use, and anyone can find the same results. That's why it's something very appreciated by our customers, is anyone that will use it, even if you are someone who knows how to use it, or someone who just used it for the first time, as there is only one button, and there is only phase 1, 2, and 3, or yes, no, you cannot find another result. It's yes or no. So that's why Jupiter is a very interesting product for our customers, and a product very reliable, because you will never cut the wrong cable. Thank you for your attention, and if you want more information, you can go on the internet, mate-sa.com.